3 is going to be a little bit different than 1 and 2 because if you read through the problem, we're not talking about max or min anymore. So this one says a package of supplies is tossed from a helicopter when it's 200 feet off the ground. The package's height above the ground is modeled by this quadratic equation right here. T is time after it's tossed. H is obviously height. How long is it going to take the package to actually reach the ground? So again, we're not talking about vertex. We're not talking about max and min. So if we think about what this would look like, on the x-axis we've got time, and on the y-axis we've got height, right? We've got a y-intercept of positive 200, so we'll just stick 200 up here. Time 0 right here is when the package is dropped from the helicopter, all right? It's not necessarily that the vertex is going to go right through the y-axis. In fact, the graph is going to do something more like this, where the vertex is going to be a little bit after the y-axis. All right, again, this is just time 0 when the package is actually dropped from the helicopter. The package is going to take some amount of time to then come back to the ground, all right? So what we need to do is set the height equal to 0 and solve the quadratic equation. Plus 28t plus 200. I would love it if this whole thing were divisible by 16, but these guys are not divisible by 16. So let's divide the whole thing by -4. Obviously, dividing 0 by -4 leaves us with 0, which is awesome. So this gives us 4t squared minus 7t minus 50. The goal is to see if we can factor this because it just makes life so much easier. But I can tell you guys right now this isn't factorable, so without me trying to go through the process, we just can't do it. So let's plug it into the quadratic formula. Now, if you use these original numbers or the new numbers, you'll get the same x-intercepts. I know these graphs would look different, but what would happen is one of them would look like this, one of them would look like this. So yes, they're different graphs, but they would end up having the same x-intercepts, all right? So it doesn't matter which set of numbers you use. I'm going to use the smaller set of numbers because they're just easier. So opposite of b, plus minus, square root, b squared minus 4ac. Super important that you double check your positives and negatives because that'll throw the whole thing off, and then over 2 times that. When you plug this into the calculator, we're going to get two values, -2.76 and 4.50. So at -2.76 seconds, the package was on the ground, probably in the helicopter waiting to take off. And then at 4.5 seconds, the package is back on the ground. So this is the answer that we're looking for, the 4.5 seconds. So how long does it take the package to reach the ground, round to the nearest hundredth? 4.50 seconds.